Okay, fine. So, good morning, all students. So, yesterday we have discussed till energy consumption problems, and you people have solved one extra problem also. Now, we will go through one more problem which is difficult. Okay, if it is difference, then we will solve even that problem. And yes, see here in example 4. The example 4 is saying that calculate the monthly electrical bill at the rate of rupees 1.45 for first 50 units and rupees 2.80 for 51 units to 100 units and rupees 3.05 for 101 to 200 units and rupees 4.75 for 201 to 300 units and rupees 5.50 for above 300 units for a residential building. Okay, with the following loads, meter rent and customer changes per month is rupees. Charges okay, charges per month is rupees 15. Okay, now the loads are that 12 number of 60 watts lamp used for 6 hours per day and 5 number of 80-watt fans used for 8 hours per day and 1 number of electric iron of 450 watts working for 2 hours a day and 3 number of electric heaters of 1000 watts working for 2 hours a day and 2 number of refrigerators of 500 watts working for 4 hours a day and 1 number of 1.5 HP motor working at 80% efficiency for 2 hours per day to pump the water. So these are all the general loads which are available in a residential building, and here the unit charges are different depending upon the units. Okay, so we know how to calculate the total energy consumption. So we will first draw this tabular form. In the tabular form, appliances, quantity, rating in watt, total load in watt, number of hours per watt, energy in watt per day, and total energy consumed in kilowatt hour per day. Okay, so here lamp appliances of 12 appliances having a 60 wattage and the total wattage is 720 and the number of hours working is 6 hours. So the total energy consumed is 4320 watt hour. Okay, but this watt hour we have to convert into kilowatt hour, that is 4.32 kilowatt hour, and the information is per day information. Okay, and fans, the fans we have 5 fans each of 80 watts, total wattage is 400 watts. This 400 how we got 5 into 80. Okay, so 400 watts and the number of hours is 8, so 3200. Now the total the kilowatt hour, the converting this 3200 in kilowatt hour is 3.2. Likewise, one electric iron 450 watts, 450 watts, and it is working for 2 hours. So total is 900 watt hour, that is 0.9 kilowatt hour. And 3 heaters, each of 1000 watts, 3000 watts, and 2 kilowatt, 2 hours. So it is 6000 watt hour. So it is 6 kilowatt hour. And 2 refrigerators, each of 500 watts, 2 into 500, 2 into 500 is giving, and yes, what extra is given here? It is 500 watts working for 4 hours. Okay, so 2 into 500 here by 80 they took, but here efficiency is not given. See, a refrigerator is also a motor, so they have considered like a motor having an efficiency of 0.8 might be. So you can take off this and take off this and calculate. Okay, and here I'm explaining directly, but this is not necessary because it is not, the efficiency of the refrigerator is not given here. Okay, so you can directly write 2 into 500, that is 1000 wattage into 4, which will give 4000. Okay, so 4000 watt hour, and the total energy consumed will be 4 kilowatt hour. Okay, but as if now I'm so here, and the sixth one is a motor. So motor, the value will be given in HP. So the rating of it is 1.5 HP, that is horsepower. So horsepower generally will be written to convert into watts, that is 1.5 into 735.5, which will give wattage. Okay, so this is an actual wattage, and this 1.5 HP motor is working at 80 percentage. So divided by 0.8. So we will get 1379.06 watts. And this watts into 2 hours will get 2758.12 watt hour. And now we are converting this watt hour into kilowatt hour. We will get 2.758 kilowatt hour. So, for explaining, I'm directly taking these values, but this will be changed. Okay, and yes, so the total is 22.178 kilowatt hour per day. So we consumed 22.178 kilowatt hour per day. So here total energy consumed per day is 22.178 kilowatt hour, and the total energy will consumed for 30 days, which will give you 22.178 into 30, that is 665.43 kilowatt hour. Okay, so I think so there is a mistake. Okay, 665.34 units. Because we know that 1 kilowatt hour is equals to 1 unit. Okay, so the monthly electricity bill, the calculation is different because depending upon the units there is a charge. So here the cost of energy plus meter rent and customer charges. Okay, these all things we have to write. We have to calculate for calculating the monthly electrical bill. So here, rupees 1.45 into 50 units. For 50 units, totally how many units we got? We got 665.34. Okay. So for first 50 units, it is 1.45. Okay. Then plus 2.80 for next 50 plus 3.05 for next 100 plus 4.75 for next 100 plus, so totally what happened? 100, the 200, so 50 and 50 here, 300 completed. Okay. Plus, if 300 above, what are the charges for 300 above? So the charges for 300 above is 5.50. Okay. So for first 50 is this, and the next 51 to 100, that is next 50 is this, and 101 to 200. That means after 100 units, the next 100 units is this, and the next 100 units is this. The value is 4.75, and after completion of 300, the units that is 300 above are 5.50. So here we have completed calculating till 300 units. This is 1 200 and 50 and 50. So totally 300 units we completed. The next remaining, so 665.34 minus 300, that is 365.34. So the next complete units will be charged, that is above 300. So the charged is 5.50. Okay, so this is an charges of units plus the rent, that is a customer charges is 15 rupees. So the total charges we will get the rupees 3016.87. Okay, so these are the 3016.87 rupees. See, so the same calculation have done in the pandemic time. So we have experienced these type of billings at the pandemic time. Everybody have got different bills. If you observe, I guess in the month of August probably. Okay, at that time the monthly charges have been changed according to the units. Okay, according to the units, if you calculate in this way, if you take your bill of August, or else I'm not sure which month, but in the time of pandemic only, you take that bill, and you can even calculate and guess what might be the difference, and how you got higher power electricity bill charges. You could able to get one idea. Okay, this is for cross checking. Yes. So this problem is a bit different. So I explained this. The rest you have to do. Already there is a solved problem. So if any doubts you'll get, you can come back to me. And yes, now what are the merits of a CFL and LED lamps over incandescent lamp? See, incandescent lamp is an yellow bulb. LED lamps and FCL lamps are like white color bulbs. You could have already seen the CFL and LED lamps. Okay, CFL lamp is a tube light, but CFL is a compact fluorescent lamp. We will generally call it as a tube light. Okay. So merits of CFL over an incandescent lamp. So what are the merits over an that yellow color bulb, that is incandescent bulb? Okay. So here a CFL gives the same amount of light as compared to incandescent lamp, but with lower power consumption and longer rated life. So here, when we compare CFL and incandescent lamp and CFL lamp lights illumination will be same. Okay, light focus will be same, but the power consumption by the CFL is less, and the life of the CFL is more. Okay, because of that, mostly CFL is preferred. And yes, now LED lamps are there. So what are the merits of LED lamps over CFL? So LED lamps are nothing but it is a light emitting diode. Okay, these are the diodes which are used for the lighting. So light emitting diode lamps have the following merits over CFL lamps and also incandescent lamps. Okay, so it has an advantage of lower power consumption, more light. If you observe, you could able to even observe the difference also when you put in a holder. Okay, so more light output, that is more illumination, long life. So here the life of the lamps will be calculated in measured in hours. Okay, so it is more hours, that is 5000 hours, more than 5000 hours, and no wastage of light, high efficiency, unlike CFL turns on instantly. So no warm up period. So what happens for CFL, it needs some time for see, we know that a fluorescent lamp, that is tube light, when we on the switch immediately, that won't glow. It will take some time and it will blink and then it will glow. Okay, but LED lamps, they will glow instantly. When you switch on, immediately they will on. Okay, so yes, so here no heat produced in LED lamps, and a low wattage power supply is sufficient for LED illumination, and it is mercury free and high durable. So these are all the advantages of LED that you have to remember. Okay, and yes, so comparison of what? Okay, fine. This is an additional information. Okay, fine. So here, that is the thermal efficiency. We have to see the definition of the thermal efficiency. So it is defined as a ratio of a heat actually utilized to the total heat produced electrically. So the efficiency, that is the thermal efficiency, is heat utilized and heat produced. So efficiency is equals to thermal efficiency is equals to heat utilized and heat produced. Okay. So heat produced is V into I into T. Okay. And heat utilized D is equals to ms into theta 2 minus theta 1 calories. So m is nothing but m is equals to mass of the water in grams, and S is equals to specific heat of water, and theta 2 minus theta 1 is equals to raise, that is change in temperature in 0 degrees. Okay. So here there is an additional information we have to know that, let us consider the case of an electric kettle. If we take an electric kettle used for some boiling point, out of total heat produced, some goes to heat the appearance like a kettle, and some is lost by radiation and the convention, etc. So the rest is utilized by heating the water. So what does it mean? Heat might be, example, if we take a kettle, that is, you can take a heater also. Okay, if you take a heater, what happens? The power which is consumed for heating of the water, in that the heating, actually what is our requirement, that water should get boiled. Okay, water should get boiled, but the heat produced totally by the power consumed for producing the heat will not totally utilized by the water. Okay, because there might be some radiation effect. It might be lost due to the variation, due to the atmosphere around it, and the heat is lost, some of the heat is lost due to the heating of this heater. Okay, the metal. So we will utilize almost like 80 percentage and 70 percentage. So hence the thermal efficiency of electric apparatus is the ratio of the heat utilized for heating the water to the total heat produced. Okay, right. Now, so what are the practical appliances for electric heating are available? So that is electric kettle, electric cooker, electric iron, space heater, geyser, infrared lamps. So these are general applications. These are general applications. uh, I think you people even know the electrical cooker because you might have studied in 10th class. Anyhow, we will go through this. Okay, so these are the electrical appliance, heating appliances. Okay, practical appliances which we use for electric heating. Okay, so here we know that the cycle is one complete set of positive and negative values of an alternating quantity. Okay, that is known as cycle. And here the cycle has, this is a maximum value, which is also called as peak value. And this is a maximum negative value, that is a maximum negative peak value. Okay, and these are some terms that the definition of time period, frequency, amplitude, these instantaneous value, maximum value, frequency, time, these are the values which are mostly used in alternating quantity. Okay, so time period, what is a time period? Time period is the time taken by an alternating quantity to complete one full cycle is called time period, and it is denoted by capital T, and it is measured in seconds. So capital T is from 0 degrees to here 360 degrees. Okay. So that is for one complete cycle. Okay. One cycle. This is a time period, that is a T. Okay. And frequency. What is a frequency? Frequency is the number of cycles per second is called the frequency of an alternating quantity, and it is measured in hertz, and it is denoted by a letter F. So here the number of cycles per second. Per second, how many cycles will be involved? That is a frequency. So here angular velocity and angular frequency, that is omega. Angular velocity omega is equals to angle turned by time taken, which is given in a formula that omega is equals to 2 pi by t, or omega is equals to 2 pi f, where f is 1 by t. Okay, so f is 1 by time period t. So frequency formula, you have to remember that f is equals to 1 by t. And amplitude, what is amplitude and peak value? That is a maximum value attained by an alternating quantity is called a amplitude or a peak value. Okay, where this peak value and amplitude will be there? Here, this is a maximum of an alternating quantity, the maximum value at here and here. Okay, that is called peak value. From this peak to this peak, we will call it as peak to peak value. And from 0 degree, from 0 to here, we will tell this is a peak value. Okay, so that is also called as amplitude or maximum value. So the maximum value attained by an alternating quantity is called amplitude or peak value. And the amplitude of an alternating voltage or current is denoted by V maximum or I maximum. If it is a current, it is an I maximum. If it is a voltage, it is a V maximum. Okay. So peak to peak is that the maximum variation between the maximum positive value to the maximum negative value. That is a peak to peak value. Okay. Which can be represented by VPP or IPP. And instantaneous value means I want to measure a value at a certain degrees. For example, here from this diagram I can say at 90 degrees I am getting a maximum value, but I want a value at 30 degrees. So what is the value of that? Okay, if I want a value at 20 degrees, if I want a value at 5 degrees, if I want a value at 101 degrees, so what is the value of that waveform? I mean that current, if it is a current, what is the value of the current at 181 degrees? Okay, so how to calculate the instantaneous value? Okay, the value of an alternating quantity at any instant is called instantaneous value, and the instantaneous values are represented by small letters like small v, small I, and small p. Okay, these are represented by small letters. So if it is a voltage, small v, if it is a current, small I, and if it is a power, it is a small p. Okay, so the instantaneous values are written like this. These are the standard form of formulas, standard form of an alternating voltage, that small v, that is instantaneous value, v is equals to Vm sine theta, or it can be written as Vm sine omega t. But omega is nothing but 2 pi f. So according to this, we know that here omega, so omega is equals to 2 pi f. So we will directly substitute the value. If we substitute omega is equals to 2 pi f, so Vm sine 2 pi f t, so V instantaneous value is equals to Vm sine 2 pi f t. Okay, and yes, if f is, that is a frequency, the f is can be written as 1 by t. So here V maximum sine 2 pi capital T into T. Okay, so this is a standard form of values given to an alternating voltage. The same can be written for a current in the same form. So here small I instantaneous current, that is capital I maximum. This is nothing but a maximum value, that is amplitude, into sine theta, I maximum sine omega t, I maximum sine 2 pi f t, I maximum sine 2 pi capital T by T. So these are all are same. Okay, all are same. And yes, so what is small v? Small v is an instantaneous value. Maximum Vm is a maximum value of an alternating quantity. Okay, and omega is an angular value, and t is a time period, and omega t is a phase angle. Okay. Yes. So here we have some problems on amplitude, frequency, and time period. We have to solve the problems. So we will see one problem that calculate the maximum value of a sinusoidal voltage if its frequency is 60 hertz and the instantaneous voltage is 10 volts at a time period of 0.003 seconds. So here we have to calculate the maximum value, that is V maximum. Okay, we have to calculate V maximum. And what is the given data? They have given frequency F is 60 hertz, and instantaneous value, that is small v, is given, that is 10 volts, and time period capital T is given, that is 0.003 seconds. Okay, so we have to write down the first given data. F is 60, small e is 10. You can write small v also. Okay, and T is equals to 0.003 seconds, and Vm is equals to how much? Okay, so this is okay. So E is equals to that small v. You can write it as small v is equals to V maximum sine omega t. We know this formula. We have studied just now. Okay. So we have to substitute the values directly. Okay. So here E is equals to 10 volts. We have to find out V maximum. So sine 2 pi, F is 60, and T is 0.003 seconds. Okay. So Vm is equals to 0.809. So Vm is equals to 10 divided by 0.809. So this part will come to the down. Okay. So now Vm is equals to 10 divided by 0.809. So Vm is equals to 12.36 volts. Okay. So this is a voltage. This is a maximum voltage. So this is how we will calculate if any unknown from this formula. From if any one unknown is found, we can directly calculate the value of that unknown value. Okay. So likewise, we have a similar problems on the same formula. Okay. So here what it has given, if we go for the second example, that find an angle of a sinusoidal waveform if 60 hertz will pass through in it for a period of 60 milliseconds. So F is equals to 60 hertz and T is equals to 10 into 10 to the power of minus 3 seconds, and angle they asked, but we know that angle theta is equals to omega t, okay, which is equals to 2 pi ft, which is equals to 2 pi 60 into 10 into 10 to the power of 3, which is equals to 3.768 radians. Okay, so this theta will be measured in radians. Okay, and if we want to convert it into degrees, we can write this pi into 180 degrees. Okay, so then we will get in degrees. So if we know the formulas, so you people have to remember the formulas, these formulas. Okay, these all formulas, so that you can solve any problem. So we have many we have three examples we have. uh, So you have to solve even some unknown problems also, which are unsolved problems are there. You have to solve even that problems.